Hey guys, it's Danny here from Disrupt Tutoring, and as always, it is a pleasure to join you. In this video, we're going to do a question from the November 2019 Grade 12 Physical Sciences Paper 2. This question deals with chemical equilibrium and the equilibrium constant. In this reaction, nitrogen monoxide gas reacts with oxygen gas and produces nitrogen dioxide according to this balanced chemical equation. The amounts of each gas were recorded over time on this graph. Additionally, we're told that the volume of the container remains constant at 3 decimeters cubed throughout the reaction, and at T is equal to 0, at the beginning of the recording, the temperature is 25 degrees Celsius and the equilibrium constant is 256. So the first question asks us to identify the stress that occurred at 20 minutes. We can see from the graph that at 20 minutes, the amount of nitrogen dioxide gas decreases sharply. This implies that some of the gas was removed from the system, and that means that the concentration of the product has changed. So that is the stress that occurred at 20 minutes. The next question asks us to use Le Chatelier's principle to explain the changes seen in the graph between 20 and 40 minutes. So Le Chatelier's principle states that if a system in equilibrium is disturbed, the equilibrium position will shift to oppose the disturbance and re-establish equilibrium. So we know that the system was disturbed at 20 minutes in, and the disturbance was the decrease in concentration of the product. According to Le Chatelier's principle, the reaction favored will oppose the disturbance. So if the concentration of the product was decreased, the reaction favored will want to increase the concentration of nitrogen dioxide, and that is the forward reaction. So that's what we see happening over here. The forward reaction is favored to increase the concentration of the product. The reactants decrease in concentration, and the product increases in concentration. So that's why we have this decrease in concentration of the reactants as they are used up to produce more of the product. Okay, so the third question asks us how the value of the equilibrium constant at 50 seconds compares to the value at the beginning of the reaction. We have already established that the only disturbance that occurred between 0 and 50 minutes was the decrease in concentration of the product. We also know that the only thing that changes the value of the equilibrium constant is a change in temperature. Since there was no change in temperature, that means that the value will stay the same between 0 and 50 minutes, so it will still be 256 at 50 minutes in. The final question asks us to write down the expression for the equilibrium constant for this reaction. And the equilibrium constant is a ratio of concentrations of products and reactants where the concentration has been raised to the power of the coefficient of the substance in the balanced equation. So the expression for the equilibrium constant for this specific reaction is given by the concentration of the product, so the concentration of nitrogen dioxide, and in the balanced equation that is multiplied by 2, so we'll raise that to the power of 2, and then we divide this by the concentration of the reactants, so we have nitrogen monoxide, and in the balanced equation that is multiplied by 2, so we'll raise that to the power of 2 as well, and then our other reactant is oxygen, so we have the concentration of O2, and that is the expression for the equilibrium constant for this reaction. Okay, so before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. Read all about them in the description below. Be sure to visit our website for more of these epic tutorial videos. If you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. Until next time, stay epic.